All right, today we're going to take some notes on special right triangles. So there are two types of special right triangles that we're going to talk about. The first is a 45, 45, 90 special right triangle. So those numbers, they have degrees here. So it's 45 degrees, 90 degrees. That refers to the angles. So this is what it looks like. You've got 45 degrees, and then of course 90 degrees because it's a right triangle. So you can see kind of that these two legs look the same, and that's actually completely true. They are the same. This is an isosceles triangle. So essentially you could also call this an isosceles right triangle. It's the same exact thing as a 45, 45, 90 triangle. Remember, isosceles means you have two of the same sides. So here's what's special about this. So if we call the leg, let's say that the leg is x. So both of these are x because the legs are the same. That means the hypotenuse is always going to be x times the square root of 2. So that's the special thing about this. So regardless of what x is, so x could be a number, x could be 3, 4, 5, the hypotenuse is always going to be whatever the leg is times the square root of 2. And like we said here, the legs of a 45, 45, 90 triangle are always congruent. So for number one, we need to find x and y. So we know one of our legs here. So again, the hypotenuse is always across from the right angle. So hypotenuse is always across from the right angle. So 8 is a leg, which means the other leg also has to be 8. So that means x is 8. So let's write an 8 here as well. So that means the hypotenuse is the leg times the square root of 2. So the leg is 8 times the square root of 2. And guess what? You don't even need to take out a calculator. You can leave it just like that. That's the exact answer, 8 times the square root of 2. And that's all you have to do. So for number 2, one of our legs is 25, which means the other leg, y, is also 25. So y is 25. And x is going to be the leg, so 25 times the square root of 2. So you can kind of see that when they give you one of the legs, it's pretty easy because you can just right away find the other leg and then times that by the square root of 2, and that's the hypotenuse. But it's a little different when they give you the hypotenuse and you need to find the leg. So here's what we do. So we know 19 is the hypotenuse, and the hypotenuse is always equal to a leg times the square root of 2. So let's solve for x first. So we're going to solve for x first. We know that 19 is equal to x, so whatever the leg is, x times the square root of 2. And now we have an equation right here. Don't get hung up on the fact that there's a radical right there. You don't really need to do a lot with it. We just want to get x alone. And so in order to do that, we're going to divide by the square root of 2 on both sides. And that's it. So x, let me do that in a different color just because they're so close to each other. So x is equal to this because these cancel out. And x is equal to 19 over the square root of 2. And since x is a leg, y is another leg, that's also equal to 19 over the square root of 2. And that's all there is to that. I will say one thing. So in Algebra 2, you learned that you can't have a radical in the denominator. So in order to get rid of it, we're going to rationalize the denominator. So 19 over the square root of 2. The way we do that is we take the denominator, square root of 2, and we multiply by the denominator over itself because that right there is equal to 1. So then what we're left with is 19 square root of 2 over 2. So that's what x and y actually are in this case, 19 square root of 2 over 2. All right, so the second type of special right triangle is a 30, 60, 90 special right triangle. So this was a little more complicated. It's not as straightforward as a 45, 45, 90. So this one, again, these numbers refer to the angles. So we've got an angle of 30 degrees, 60 degrees, and of course, again, 90 degrees because it's a right triangle. So here's what happens with this one. If the shorter leg, so the shorter leg is going to be across from the shortest angle. So the shorter leg is always across the triangle from 30. So if we call the shorter leg X, and we call the longer leg, well, we don't call it anything, sorry. The longer leg is the one across from 60. That's always going to be X times the square root of 3. And then the hypotenuse, so this is X times the square root of 3. And the hypotenuse is always going to be 2 times X. So hypotenuse is always 2 times X. And like I said, the hypotenuse is always across from the 90. The shorter leg is always across from the 30, and the longer leg is always across from the 60. So let's do some problems with that. So in this case, they give us 5, so they give us the shorter leg. So that kind of makes life easy because now let's look for the longer leg. So the longer leg is across from the 60. So the longer leg is X. So in order to find that, you just take the shorter leg. So 5 times the square root of 3, and that's it. So that's the longer leg, 5 times the square root of 3. And to find the hypotenuse, it's 2 times the shorter leg. So it's 2 times 5, which is 10. All right, so next one, this time they give us the shorter leg again. This triangle is just kind of flipped on its side, but the 14 is across from the 30, so they're still giving us the shorter leg. So in order to find, in this case, X is the hypotenuse, because X is across from the right angle. So the hypotenuse is 2 times the shorter leg, so 2 times 14 is 28, and Y is the longer leg. So Y is a shorter leg, so 14 times the square root of 3. All right, so for number 6, this time they're giving us the hypotenuse. All right, so remember that the hypotenuse is 2 times the shorter leg. So if they give us the hypotenuse, the next thing you need to find, or the easiest thing to find, I should say, is the shorter leg, because in order to find the shorter leg, you just need to divide the hypotenuse by 2. Because we know the shorter leg is X, so 32 equals 2X. And if you divide by 2, X equals 16. And once you get the shorter leg, you can find the longer leg, because the longer leg is the shorter leg, so 16 times the square root of 3. We have 3 more examples for 30, 60, 90 triangles. So number 7, they give us the hypotenuse again. So like I said before, the easiest thing to find is the shorter side. So in this case, the shorter leg is Y. So 46 equals 2Y. So to get Y alone, we divide 46 by 2 and we get 23. To find X, X is the longer side because it's across from 60. It's the longer leg. So that is just going to be 23 times the square root of 3. And that's it for that one. So in this case, I would say usually the hardest scenario is when they give you the longer leg. So Y is the shorter leg, 20 is the longer leg, X is the hypotenuse. Because, again, as always, the hypotenuse is across from the 90. The longer leg is across from the 60. You can also just tell that the 20 is longer than the Y. So we know that the longer leg is equal to the shorter leg, which is Y, times the square root of 3. So to get Y alone, we divide by the square root of 3 on both sides. And then Y is equal to 20 over the square root of 3. So because these square roots of 3 cancel out, Now, on the bottom here, I'm going to rationalize the denominator again. So 20 over square root of 3 times the square root of 3 over the square root of 3 it gives us 20 times the square root of 3 over 3, because again, the square roots cancel each other out, and you're just left with what's on the inside, which is 3. So that's what y is, 20 square root of 3 over 3. And then x, so x is the hypotenuse, and that's 2 times whatever the shorter leg is. So it's 2 times y. So if we were to multiply that, let's do it down here. So x equals 2 times 20 square root of 3 over 3. So we have 2 times a fraction, so we just make that 2 over 1. Then we multiply the numerators, which leaves us with 40 square root of 3. And then the denominators, 1 times 3 is just 3. And then for the last one, y is our hypotenuse, x is our shorter leg, and 9 square root of 3 is our longer leg. So if that's our longer leg, let's find our shorter leg now, because we know that the longer leg is equal to the shorter leg times the square root of 3. So this actually works out pretty nicely for us because this already has a square root of 3 in it. So if I divide by square root of 3 to get x alone, these cancel out to get x alone, but these also cancel out, and we're just left with 9. So x is 9, and then y, the hypotenuse, is 2 times the shorter leg, so 2 times x, which is 18. That's it for special right triangles. Those are your notes.